So solving equations in one variable, rational equations. If you have a variable in the denominator and you're multiplying each side by variables to get rid of the variable in the denominator, then you're going to make extra solutions. Extra solutions in math are called extraneous solutions. So we have to check our answers for extraneous solutions. Looking at this, since I have a variable in the denominator, I'm going to have to multiply each side by what? X minus 3, what is in the denominator. Okay? So if we do the distributive property, we get x times x minus 3 plus x minus 3 over x minus 3 equals 1 times x minus 3, which is x minus 3. Now, when you have x minus 3 over x minus 3, the whole thing cancels with the whole thing, not just x and 3 and 3. The whole thing and the whole thing. Okay, it's got to be a whole quantity at a time with a whole quantity at a time. When those cancel, what do they equal? Not 0, but 1. So if we distribute here, we get x squared minus 3x plus 1 equals x minus 3. Now move the x to the other side, move the 3 to the other side. So subtract x and add 3. Subtract x, add 3. X squared minus 4x plus 4 equals 0. So it's x minus 2 times x minus 2 equals 0. So x equals 2. If you plug a 2 in there, is 2 plus 1 over 2 minus 3, which is negative 1. 2 plus negative 1 equal to 1? Yep, that's the answer. Okay? And since both solutions were the same number, you didn't have any extraneous solutions. Okay, let's try this one. What do we multiply by? X. So everything basically gets multiplied by x. The x's cancel here. So x squared plus 2 equals 3x. So x squared minus 3x plus 2 equals 0. X minus 1 times x minus 2 equals 0. X equals 1. X equals 2. Solving the equation. So if we stick a 1 in there, 1 plus 2 over 1 equals 3. Check. If we put a 2 in there, 2 plus 2 over 2 equals 3. Check. Both of them work. No extraneous solutions there. Whoops. I did not mean to do that. And now it won't go. Oh, I'm such an idiot. All right. How do I make it smaller? I don't know. There we go. All right. Here, the least common denominator is this, because this factors into x minus 1, x minus 3. So if we multiply this numerator by x minus 1 times x minus 3, these cancel. So I just get 2 on this side. If we multiply this by x minus 1, x minus 3, the x minus 1's cancel. So it's 2x times x minus 3. If we multiply this times x minus 1 times x minus 3, x minus 3's cancel, then we get x minus 1. So just do the math. X minus 1 plus 2x squared minus 6x equals 2. So 2x squared minus 5x. If we move the 2 over, we get minus 3 equals 0. Now we got to factor that. 2x and x. What are the factors? Well, it's 1 and 3. So if I put a 1 here and a 3 here, I get 6x here, 1x here. Well, I want a negative 6x plus 1x, so I need a plus there and a minus here. So then I get a negative 6x plus 1x equals negative 5x. So x equals -1/2, and x equals a positive 3. Now, if we put a 3 in here, I get 1 over 3 minus 3, 1 over 0. Can I have a 1 over 0? No, so that's an extraneous solution. If I put a -1/2 in there, I get 1 over -3.5 plus -1/2 times 2 is -1 over -1/2 minus 1 is -1.5 equals 2 over, and then if we put a -1/2 in there, we get 1/4 minus 2 plus 3, or 1/4 minus 1, which is -3/4. If you put that into your calculator, I think that actually might work out, because this is -7/2, so this is like 2/7 negative. This is -3/2, so plus 3/2 equals -8/3. And doing the math, it works. All right, find the dimensions of a rectangle with a minimum perimeter if its area is 300 square meters. I think that's in the second set of problems. So we're not going to worry about that right now, because that's what we'll have on Thursday. So we're not going to worry about that. Discard. So what kind of problems will we see today? We will see these. Boom. I might need my graphing calculator, so I won't get rid of it yet. So let's look at this. It says solve the equation and check your answer. What would you multiply everything by here? 2. Multiply this by 2, this by 2, and this by 2. The 2's cancel here, cancel here, cancel here. So it's q plus 2 plus q minus 11 equals 1, or 2q minus 9 equals 1, 2q equals 10, q equals 5, and that's going to check, trust me. What would you multiply here? By q on both sides. So q squared plus 5q equals 36. Move the 36 over, solve, and so on. Okay? Make sure you check your answers. On this one, you'd multiply by x minus 8. This one by x. All right, let's do number 4 here. Number 4, if we multiply both sides by x, we get x squared plus 12, because x over x cancels, equals 7x. So x squared minus 7x plus 12 equals 0. What are two numbers that add up to be -7 that multiply to be 12? Add up to -7, multiply by 12. -3, -4. So the solutions are -3 and -4, or actually 3 and 4, because x minus 3 equals 0 is 3 and 4. So you want to find the graph that crosses at both 3 and 4? Well, it's graph D crosses at 3 and 4. You just can't see that they're crossing at 3 and 4. So 3 and 4 is also the answer down there. Okay? Let's do this one here. So what's the least common denominator? Well, this factors into x times x plus 4. So that's going to be the least common denominator, x times x plus 4. We'll multiply the top of each equation by x times x plus 4. The x's cancel here, so it's 5 times x plus 4. The x plus 4's cancel here, so it's x times x. The x plus 4's and the x plus 4's cancel there, so it equals 16. So 5x plus 20 plus x squared equals 16. So x squared plus 5x plus 4 equals 0. If we subtract 16 from each side, factor x minus x plus 1, x plus 4. So the answers are x equals -1 and -4. Can you see right now one of them's an extraneous solution? Which one would be an extraneous solution right off the bat? -4, because if you stick that in, it'll give you a 0 in the denominator. Okay? So there are, on this one, this crosses the x-axis at -5. Does it cross the x-axis at -3? No. So -3 is the extraneous solution because it's not graphed. Okay? All right. Up to there. There we go. So I will put the second assignment out there and you can play with it. Should be out there now. On Thursday, we'll do the last 2 sections of the chapter. Then next week, we'll do a practice test and start off the new quarter with a test.